This video demonstrates a four-letter word clock that I built that's based on a very old design originating back in the 1970s that used discrete logic to generate a random sequence of four-letter words. This clock is a little bit smarter in that it uses a database that was designed by the Akafugu Corporation, and it's based on a study that was done in the early 60s in England, where some researchers took a series of seed words, I think about 100 words, read them off to a group of participants and asked them to name the next word that came to mind after they heard one of these seed words. Then the responses were used to generate additional responses. And they built a very large database of word associations. So the words are not necessarily syntactically related to one another, but they do have a psychological connection. And some of them reflect some of the biases of the early 1960s and of English culture. So it's kind of an interesting sequence of words. And you'll notice as these words are scrolling by on the screen here that each consecutive word is usually related to the one before it. Eventually the relations run out and it'll start with a new random word. But it produces a rather interesting display. Now, interspersed with the series of words in the clock will display 5 words from the database randomly and the associations, and then it'll display the time and date very quickly, and then resume with the five additional words. There's optionally another mode that can be used that generates entirely random sequences of 4-letter words. And you can see there's no filter for slightly off-color or obscene words whatsoever, and you can see that those are somewhat related, so it's a pretty good example. So right now we're in the relational database mode. Now the database is stored on an external I2C double EEPROM that is read by the Atmega 328P microcontroller that does all the functions of generating the words and handling the display, refresh, and so forth on the screen. So that's the basic function. Now, an added feature of this is that every 10 minutes I have a series of 110 phrases that are also stored in the double EEPROM, and those will display and scroll right to left across the screen every 10 minutes to provide some additional interest and inspiration. Optionally, the clock mode can be switched off, and the word generation mode can be selected by a simple procedure by holding one of the top buttons down during power up. The top buttons provide control of setting the real-time clock that's inside of the box. First one sets the hour. Second sets the minutes. When the minute is set, it automatically resets the seconds to 0. And then the final one, if you watch the flashing decimal point there, freezes the seconds as long as it's held down. And when it's released, we'll resume the count, and that enables synchronizing to a external source of calibration. To set the day, the month, the first and second buttons are held together, so the month can be set. To set the year, the second and third buttons are held down, thusly, and to set the day of week, all 3 of the buttons are held down. And that's basically it. Now let me advance up to just before a 10-minute, or right at a 10-minute boundary here, and we'll see the phrases actually display. There we go. So any time is the right time for hugs. Well, that's nice. Some of them are much more profound than that. So then we'll get another word, and we should get another phrase as long as we're on the 10-minute mark. When a person can no longer laugh at himself, it is time for others to laugh at him. So again, another rather profound word. They all relate to somehow to time or time management. So they're kind of good. They're kind of interesting, and they do add some interest to the whole thing. So that's basically it. Oh, one more. So it was kind of a fun project to do. The display is driven by an interrupt refresh routine that updates it so every 100 at a 100 hertz rate. And the microcontroller is direct driving all of the segments on there. I'm not using a shift register or anything. So there were just enough pins on the Arduino to actually allow direct drive using a multiplexing scheme. So it results in pretty good image brightness, and it saved a lot of pins on the microcontroller. The displays use a little kind of an unusual scheme. Each digit has 2 common cathodes, so we only have to apply 7 of the 14 alphanumeric segments at any one time. So that saves quite a few pins. I think if you were to use a more common display that had a single common cathode and 14 segments that needed to be presented to the display for each digit, I don't think you'd have enough pins on there. So unfortunately, to do an exact duplicate of the clock, you have to find some of these rather uncommon displays. They are out there. I had a supply of these in a box that I had been planning to use for many years, and finally decided to build something with them. So the design is kind of customized around those displays, but if you can find the part number that's listed in the instructable, it should work just fine. So all in all, kind of a fun project using a couple of other technologies and techniques gleaned from other people's clocks with some unique code that I wrote for it.